So take a minute to read this question here. We've got two objects moving along a straight line. Object A is given a position and a velocity, and object B is given a position equation. So if we think about some line here, if this was A and this was B, and A was moving to the right and B was moving to the left, they'd be moving away from each other. But if A was moving to the left and B was moving to the right, they'd be moving toward each other. So in order to do this problem, I need two things. I need the position and the velocity of each. Okay, so now we're going to look to see what kind of information we're given. Well, object A at time equals 2 has a position of 4. So we don't know where the other one is, but we're going to say this one's 4 at t equals 2. And it gives us a velocity as 2t minus 5. So that means our velocity equals 2 times 2 minus 5. Well, that's negative 1. And if we have negative velocity, that means we are moving to the left. Now we'll look at what we're given for object B. This was A. Here's B, potentially. We don't really know where it goes, so let's wait on labeling it. The x value is its position will be 2 squared minus 3 times 2 plus 2, or 4 minus 6 plus 2, that's equal to 0. So as we look at this, it's actually not here as we had originally drawn it, but it's over to the left of point A. So here's point B at x equals 0. Now we need to know which way it's going, and its velocity, we'll call it velocity B of t, will be the derivative of its position, or 2t minus 3. When I plug that same 2 in, because we want to know at time 2 what's happening, we'll have 2 times 2 is 4 minus 3 is 1. Well, that's a positive velocity. If my velocity is greater than 0, then I'm moving to the right. And so now this object is moving to the right because v was equal to positive 1, where in the other case the v was equal to negative 1. So as shown by our arrows here, these objects are moving toward each other.